Have a nice day, my dear student. Today we will discuss about armature winding, which is lap and wave. This is my lecture 4 in electrical machine. Day by day I will cover the all syllabus of electrical machine. Myself Santanu Noskar, Assistant Professor of Electrical Department, GKCM JIS Group. This is my mail ID santanu.uyt@gmail.com and santanu.noskar_gkcm@gisgroup.org. And this is my Facebook page, Being Electrify with Santanu. You can like this page. Okay, so armature winding. The armature winding is the most important part of the rotating machine. It is place where the energy conversion take place. The mechanical energy is converted into electrical energy, and the electrical energy is converted into mechanical energy. The armature winding is mainly classified into two types: lap winding and wave winding. Okay, actually the armature winding is closed type and open type. The closed type have Grammy ring winding and drum type winding. In drum type winding there are two type of winding: lap winding, wave winding. In lap winding there are two type of winding: simplex lap winding, multiplex lap winding. Actually there are also triplex lap winding, but in our syllabus we will not discuss about triplex lap winding. In wave winding there are simplex wave winding and multiplex wave winding. So first of all we will discuss about lap winding. So in lap winding, number of poles P equals to number of parallel path A. Okay, this is mainly used in low voltage high current machine. In lap winding, the conductors are joined in such a way that their parallel paths and poles are equal in number. The end of each armature coil is connected to the adjacent segment on the commutator. Okay, look here. The end of each armature coil is connected to the adjacent segment on the commutator. The number of brushes in the lap winding is equal to the number of parallel paths, and these brushes are equally divided into negative and positive polarity. Okay, and also if a machine has P poles and Z armature conductor, then there will be P parallel paths and each path will have Z by P conductor in series. Okay, now simplex lap winding. In simplex lap winding, the terminal end of one coil is joined to the commutator segment and the starting end of the next coil is placed under the same pole. Also the number of parallel path is similar to the number of poles of the winding. So look here, the terminal end of one coil, here this is the terminal end of one coil, is joined to the commutator segment. Okay, this is the commutator segment, and the starting end of the next coil is placed under same pole, and this is the starting end of the next coil. Okay, so these two coil is placed under same pole. Okay, also the number of parallel path is similar to the number of poles of the winding. Next, duplex lap winding. In duplex lap winding, the number of parallel paths between the pole is twice the number of poles. The duplex lap winding is mainly used for heavy current application. Such type of winding is obtained by placing two similar windings on the same armature and connecting the even number commutator bars to one winding and the odd number to the second winding. Okay, so what is the main thing? Such type of winding is obtained by placing two similar windings on the same armature. Look here, two similar winding. Okay, also look the next, 'next' 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 So there are two similar winding. So these are the lap winding. Now we will go through the wave winding. So the number of brushes is equals to the number of parallel paths. The number of parallel path equals to 2. The number of brushes also equals to 2. This is mainly used in high voltage low current machine. In wave winding, only two parallel paths are provided between two positive and negative brushes. The finishing end of one armature coil is connected to the starting end of the other armature coil. Commutator segment at some distance apart. In this winding, the conductor are connected in two parallel paths irrespective of the number of poles of the machine. The number of brushes is equals to the number of parallel paths. Okay. And also one thing, the conductor are split into two parallel paths. We know that, and each parallel path has Z/2 conductor in series. And also this winding look like a wave shape. That's why this is called wave winding. Now the difference between lap winding and wave winding. Okay, so these are the difference. First definition: for lap, the coil is lapped back to the succeeding coil. For wave, the coil of the winding from the wave shape. Connection: the end of the armature coil is connected to an adjacent segment on the commutator. For wave, the end of the armature coil is connected to the commutator segment some distance apart. Parallel path: the number of parallel paths are equal to the total number of poles. For wave, the number of parallel paths is equals to 2. For other name, parallel winding or multiple winding, lap winding name parallel winding or multiple winding. And for wave, two circuit or series winding. EMF is less for lap and more for wave required. Number of brushes equals to the number of parallel path for lap, and for wave which is 2 types: simplex and duplex winding. Also there is triplex winding. This type progressive and retrogressive wave winding. Efficiency is less for lap, high for wave. Additional coil equalizer ring required, and for wave dummy coil required. Winding cost is high for lap, low for wave. Use in low voltage high current machine. It is used in high voltage low current machine. So thank you. This is my Facebook page and this is my YouTube channel. You can subscribe my YouTube channel and like my Facebook page.